So students, in this video we are going to discuss about hydraulic coefficients, and these are the terms which are related with the term orifice. So first of all, let us see what do you mean by orifice. So here you can see a tank which is in which a hole is provided. So orifice is nothing but a opening which is provided at the side or the bottom of the tank, with the help of which we can measure discharge through it. Okay, and the shape of this orifice could be rectangular, circular or triangular. Here H represents the head of water which is available in the tank from the center of the orifice, and this is the jet of liquid which is coming out from this hole. So when the jet of liquid is coming out from this hole, as soon as it leaves the hole, the fluid or the jet will contract first before it again expands. Okay, so if I can represent, then this is the area where the cross sectional area of this jet of fluid will be minimum, and that area is known as vena contracta. Okay, so vena contracta is defined as a term which represents the least cross sectional area of the jet of fluid as soon as it leaves the hole. The velocity of the jet of fluid will be maximum at the vena contracta, and the pressure will be lowest or minimum. So now let us see that how these coefficients relate with the orifice. So first of all, starting with the coefficient of velocity. So coefficient of velocity CV is defined as the ratio of actual velocity of fluid at vena contracta to theoretical velocity. Okay, so actual velocity will be represented by V and theoretical velocity will be represented by 2gh, where h represents the head of water from the center of orifice which is present in the tank. So this is known as coefficient of velocity CV, which is the ratio of actual velocity of fluid at vena contracta to theoretical velocity. So actual velocity is V, theoretical velocity is under root of 2gh. The value of CV generally ranges from 0.95 to 0.99 depending upon the shape, size of the orifice and also the head available over the center of the orifice in the tank. And generally for sharp edge orifice, the value of CV which is considered is 0.98. Okay, now coming to second kind of hydraulic coefficient, which is coefficient of contraction. So coefficient of contraction is defined as area of jet at vena contracta. Okay, area of jet of fluid at vena contracta to area of orifice. So coefficient of contraction is defined as the area of jet of fluid at vena contracta to the area of orifice, and that is, suppose AC is the area of jet at vena contracta and A is the area of orifice. The value of CC also varies from 0.61 to 0.65 with an average value of 0.61 to 0.69 with an average value of 0.64. Okay, and the third and the most important hydraulic coefficient is coefficient of discharge. So coefficient of discharge CD is defined as actual discharge through orifice upon theoretical discharge. Okay, so we know that actual discharge will be the multiplication of actual velocity into actual area upon theoretical velocity into theoretical area. Now from here we can see that actual velocity upon theoretical velocity is nothing but the coefficient of velocity, that is CV, into actual area upon theoretical area also represents the coefficient of contraction CC. So this is the most important relationship among the three hydraulic coefficients, that is coefficient of discharge is equals to coefficient of velocity into coefficient of contraction. The value of coefficient of discharge ranges from 0.61 to 0.65 with an average value of 0.62. Okay, so these are the general values. 0.98 is the value of coefficient of velocity for sharp circular edge orifice. Value of Cc will be 0.64 and value of Cd will be 0.62, and this is the most important relationship that is generally asked in competitive exam also, that what is the relationship between the three hydraulic coefficients. So the three hydraulic coefficients which are related with orifice are coefficient of velocity, coefficient of contraction and coefficient of discharge, and they are related as Cd is equals to Cv into Cc. Thank you.